Another way to set up a circuit is to have our battery again, but now here are my resistors, and instead of putting them in series where you have to put them in a row, let's put them in what's called parallel. So now I have a resistor. Let's use a different color. I like the orange here. Here's a resistor that's here. We'll call this one resistor 1. And then here's another one, resistor 2. Now here they are connected to the same part on the battery. So they are both at the same potential. So the potential across 1 and the potential across 2, which is located here and here, between here and here. So the voltage of the battery is equal to the voltage across 1, which is equal to the voltage across 2, because they're connected to the same place in the circuit. But now, the current that flows through here, when it gets to this point right here, this is a junction, some of it's going to go this way and some of it's going to go that way. So when it's coming in, because I'm going from the high potential side to the low potential side, I have two places to go. I could go here first, or I can go here first. How do I know which way it goes? Well, it kind of all goes out in the wash. So I have the current through number 1, and then I have the current through number 2. So that means the current coming out of the battery, which is this one here, equals the current through number 1 plus the current through number 2. Let's do some math now. So V equals IR, I forgot my hats, but I have current, so I equals V over R. So that means the current through the battery is I1, which is V1 over R1, plus V2 over R2. But V1, V2 equals V1 equals the V of the battery. So then I can just make this the V of the battery over R1 plus the V of the battery over R2. I'm going to pull out the V of the battery, and this turns into 1 over R1 plus 1 over R2. This is the same as this. Because, so this becomes your equivalent resistance. So the current through the circuit is the voltage across the circuit plus the equivalent resistance in series, in parallel. So the equivalent, 1 over the equivalent resistance is 1 over R1 plus 1 over R2, 1 over R3, whatever. This is called adding harmonically. So what this means is as you add more and more resistors, there are more and more paths to go, so the resistance actually drops. Let's go back to our circuit from the series circuit. So I have I don't like the way this one's drawn out. So let's flip it around a little bit. And then here's your next one. So we have 12 volts. And now we have a 3 ohm resistor and a 4 ohm resistor. My question again is, what is the equivalent resistance? And number 2, how much current is coming out of the battery? How much current is coming out here?